All right, today we are diving headfirst into one of the biggest, most mind-bending ideas in all of science, the multiverse. Is our entire universe just one tiny bubble in some vast cosmic ocean? And get this, could a strange feeling you've probably had your whole life actually be a clue? You know that feeling, right? Déjà vu. That super weird, unshakable sense that you've lived this exact moment before. Well, according to some pretty wild theories out there, this little glitch in our brains might be way more than just a trick of the mind. It could be a window into another reality. So the idea, which the famous physicist Michio Kaku has talked about, goes something like this. If parallel universes are real, maybe, just maybe, their timelines could cross for a split second. And right at that intersection, information, what our brains might interpret as memories, could leak from their universe into ours. That's what could be triggering that bizarre feeling of familiarity. It's a fascinating thought, even if we can't prove it. And this whole concept has led people to look at strange coincidences in their own lives a little differently. I mean, take this one bizarre story that went viral a while back. For some, it's the perfect example of this kind of cosmic crossover. Okay, so back in 2017, a woman posts this baffling story on Reddit. She gets a text from her husband's number that says, "Who is this?" But he's literally fast asleep right next to her. The person on the other end says her number is saved in his phone as wifey with a heart. But when she checks her actual husband's phone, nothing. No record of any message sent. So was it just a weird technical glitch? Or was it something stranger, like a brief, bizarre connection to a parallel world? Now, stories like that are super fun to think about, but let's be real, they aren't scientific proof. To find any kind of real evidence, we have to go beyond personal stories and dive into the fundamental laws of physics. And that journey starts at the very beginning of our own universe. We all learned the basic story of the Big Bang in school, right? Well, it turns out the version most of us know might only be half the picture. The full story isn't just about how our universe was born, it might also be the story of how the multiverse was born too. So, the standard view we all know is that one Big Bang created our one universe, which then expanded really fast. But a more complete theory suggests something bigger. It says the Big Bang didn't just create our universe. It created a vast inflating space, almost like a cosmic incubator, where tons of different universes could pop into existence. How is that even possible? Well, to wrap our heads around it, cosmologists use a surprisingly simple analogy, a pot of boiling milk. And it's actually a pretty brilliant way to visualize an incredibly complex process. So picture that pot of milk. On the surface, it might look pretty calm, but underneath it is churning with energy. Hot particles are unstable and they're all trying to rise to the surface where they can cool off and become stable. The very, very early universe was kind of like that. It looked stable, but it was just seething with this incredible energy and quantum fluctuations, and everything was trying to settle down into a lower energy state. Physicists have a name for this temporarily stable, high-energy state. They call it a false vacuum. Think of it like a ball resting in a little dip on the side of a huge hill. Sure, it's stable for the moment, but it's not at the very bottom of the hill where it would be truly stable. The entire early universe was stuck in this false vacuum state. So how does the universe get from that temporary dip all the way down to the bottom of the hill to what we call a true vacuum of ultimate stability? Well, there are two ways it could happen. There's a slow path, where particles have to gain enough energy to climb over a barrier, kind of like in a normal chemical reaction. But then there's a fast path, a shortcut, and that involves forming bubbles. This shortcut is a real mind-bending thing that happens in the bizarre world of quantum mechanics. It's called quantum tunneling. It basically allows a particle to pass through an energy barrier instead of having to climb over it. It's like our ball on the hill suddenly just appearing at the bottom without ever rolling down. It's weird, but it's real. And this is the absolute core of the whole idea. According to the theory, as particles in the early universe quantum tunneled from that false vacuum to the true vacuum, they weren't just finding stability. Each time a particle tunneled through, it inflated a brand new bubble of space-time, potentially with its own unique physical laws. They created countless bubble universes. And our universe? It's just one of those bubbles. For decades, this was just an amazing, mind-bending theory. But not long ago, a team of physicists at the University of Trento in Italy actually ran an experiment, and they observed this exact bubble-forming process in a lab. They basically recreated a key moment from the dawn of time. Okay, so let's break down how on Earth they did this. First, they made their own little false vacuum. They did this by supercooling sodium gas until it became something called a Bose-Einstein condensate. This is an exotic state of matter where thousands of atoms start acting like one single giant atom. Then they used a magnetic fields to get all these atoms aligned, and they zapped them with radiation to copy the quantum fluctuations of their early universe. And then they just watched. What they saw was incredible. Once the radiation they were using hit a very, very specific frequency, which they labeled delta F, something amazing happened. Atoms in the gas started to quantum tunnel. They spontaneously flipped their magnetic orientation and formed these distinct bubbles of a more stable, lower energy state. They literally watched the very mechanism that could create a bubble universe happen right there in their lab. So, this is a huge deal. It's a landmark experiment. It shows that the physical process for making bubble universes isn't just a wild idea. It's real and observable. But does it actually prove that the multiverse is real? Let's weigh the evidence. So we've got a plausible theory, and now we've got a lab experiment that shows the mechanism behind it is real. Is that it? Definitive proof? Well, the short answer is not quite. Here's the bottom line. On one hand, the Trento experiment is a massive win for the theory. It proves that the bubble-forming mechanism isn't science fiction. It's real physics. The big challenge, though, is that to prove other universes actually exist, you need to see them. You need direct observational evidence. And so far, we just don't have it. Our best baby picture of the cosmos is something called the cosmic microwave background. It's the faint light left over from the Big Bang. Now, the thinking is, if other bubble universes had formed near ours, they might have bumped into us and left a kind of circular bruise or a cold spot in this afterglow. Scientists have been looking for these signs for years, but so far, they've come up empty. But here's the thing about science. The story is always changing. What if we just haven't been able to see the evidence yet? I mean, brand new data from the James Webb Space Telescope is already making some scientists think the universe might be twice as old as we've always believed. The story of our origins is clearly far from finished. So I'll just leave you with this thought. If we're just now realizing we might not even know the true age of our own universe, what other massive secrets are still out there, just waiting for us to find them?